Good day, everyone. I can't believe we're doing this, but we're here. I'd like to address this myth about aircraft not using fuel, specifically commercial airliners, and set the record straight using real world examples, references, videos, and a bunch of other proofs that seem to be overlooked when discussing this topic. And I've picked these four individuals not because there's any hardship between us. I actually follow some of them and agree with most of what they're saying. But I've picked them because they're very prominent in my feed, and I'm very concerned that the message that they're propagating is reducing their credibility for other messages that they're trying to get across. And I'm also concerned that some of them may be controlled in the sense that they are deliberately trying to discredit other messages that we're trying to put out to help others. And after watching this video, I hope that they'll reach out to me because I have tried contacting them privately through messages or commenting on their posts. However, nobody has responded to me. I do have quite an extensive aviation background. My background is actually electronics engineering with a very strong mechanical background. And more importantly, I have avionics and flight training experience at the airport or airline transport category level. Now, I'm not a pilot. I don't have a pilot's license. However, I was trained by military and commercial airline pilots when I worked at a flight center where they trained pilots to do the job that they do, which is taking you around the world to your favorite vacation destinations. So, yes, I have formal pilot training at the commercial airline level. And I did that for about 5 years as a level D simulator technician. I've also flown a Cessna 152 and a Piper Archer 2, so I do have experience flying. And I've also been very close with the maintenance room and seen turbojet engines and turboprop engines and fuel lines, and also know quite a bit about the industry. So this is going to be a very long video. I'm going to attempt to answer the myths or debunk the myths in the first 5 minutes, and then the remainder of the video will go into depth with examples and calculations and video proofs and things of that nature. And I hope that if these gentlemen see this video, will reach out to me. Again, there's no hard feelings here. I just want to know who is on par with getting proper information out to the public. I'd like to begin with the first myth that I believe started from a misconception of how a jet engine is started. And we're going to go to something a little more common to all of you, is your vehicle, your car engine, and how it starts. And the first question I'm going to ask these four individuals is, how does your vehicle engine start? What mechanism and what energy is used to initially start your car's engine? And if you said fuel, you would be wrong.
Surprisingly simple, yet immensely powerful device, the starter motor. This thing is the heavy-duty muscle that turns your dead engine block into a purring machine your car makes. But have you ever stopped to think about what actually makes that happen? It's not the fuel, it's not the spark plugs, and it's definitely not the battery alone. It's this compact, surprisingly simple, yet immensely powerful device, the starter motor. This thing is the heavy-duty muscle that turns your dead engine block into a purring machine. Here's the deal. Your engine needs to be turning at a decent speed, about 100 to 200 revolutions per minute, or RPM, to suck in air, compress the fuel, and fire up reliably. Problem is when your car is off, the engine is just a big, heavy, inert chunk of metal. It has no power of its own. The starter motor's function is singular. To draw a massive burst of power, we're talking hundreds of amps from the battery to provide that initial, heavy, forceful rotation. It's a temporary, heavy-hitter electric motor designed for one job only, to crank the engine until it can fire on its own power.
So if you already didn't know, now you do. The vehicle engine requires electricity, voltage and current from the battery to turn the starter motor in order to move the pistons, create compression and heat to light off the fuel mixture. You simply cannot just light off the fuel in the combustion. That's why you have the timing of the spark when the piston is almost at the top, lights off the fuel, the amount of time for the fuel to expand after the spark happens, the expansion of the fuel pushes the piston down, and the cycle continues. Now with a jet engine, it's relatively the same, but we don't use electricity per se. We're going to use compressed air to spin the turbines to create compression and heat in the combustion chamber in order to light off the fuel mixture. So I think that's where the misconception comes in, where, oh, airplane engines run on compressed air. No, they don't. They require compressed air to spin the turbines to create compression, which is required. So this myth about engines needing compressed air or running on compressed air is totally blown out of the water, because somebody saw an air cart fire up a jet engine and assumed that it just ran on compressed air and didn't realize that you need to create the heat and compression in order to light off the fuel mixture. The compressed air is used to spin the turbine blades initially before the fuel is introduced into the combustion chamber so that the jet engine can start.
Through the combustor, releasing a jet of super high-powered gas. The design shown here is an annular combustor, meaning ring-shaped. Compressed air enters the inlet nozzles. Each nozzle is coupled with a fuel injector and is designed to swirl the incoming fuel and air for an even mix. A couple of igniter plugs.
While we're discussing turbofan engine design, let's discuss a couple other myths surrounding this topic. One being, why is the air exiting the engine not hot and burning people standing behind the airplane, for instance, on a beach while they watch the airplane take off? The other, why can't we see flames coming out the back of the engine? And let's start with that one. That's because the jet engine has a combustion chamber which contains the flame, and that is used to efficiently move the turbine blades to spin the incoming air through the engine to create thrust. If that heat was escaping out the back of the engine, it wouldn't be enough to turn the turbine blades in order to create that thrust. So that is why all that heat is contained in the combustion chamber, so it can be forced through the blades of the turbine. Just like your car engine has a cylinder, it contains the air-fuel mixture, the ignition, the expansion, so all of that energy can be used to move the piston. If it was escaping out the exhaust, then your car wouldn't move very effectively. So that's why you can't see flames shooting out the back of the engine, except for a couple instances like when there's a compressor stall, engine fires, of course, during the initial light-off, when the air-fuel mixture is not optimal, you can see a little bit of flame shooting out the back. Going back to the people on the beach, they're not getting burned because what you see is, or the design of the turbofan engine it's also referred to as a high bypass system, which means most of the air going through that engine is getting directed around the turbine section to create the thrust. And there's a little bit, approximately 20% of that air is getting used for actual combustion to drive the engine to make the thrust. If it was the other way around, there wouldn't be enough thrust produced to move a multi-ton aircraft. Sucking in cold air from the front, and 80% of that air mixed with a little bit of exhaust heat, it gets cooled. The heat dissipates, obviously, the air moving faster, plus the distance from those people on the beach to the actual engine also dissipates heat just through the atmosphere before it reaches a few hundred feet back. You're not going to feel that heat. You're going to feel the pressure. In the next video, I'm going to discuss the fuel capacity, the fuel weight, and this nonsense about aircraft using energy from the upper atmosphere. And I'm also going to ask some very hard questions about how these, well, I call them no fuelers, no fuel for airplane use. That's how I came up with that term. I want to ask these no fuelers how the aircraft is controlled by the pilot if it's using energy from the atmosphere, what buttons and levers control the thrust and that sort of thing, and where all these air compressors are hiding and why you can't hear the air compressors in the airplane. Where are the pipes forcing this compressed air to the engines if you're one of those that believe airplanes run on compressed air? Like this, there's so much nonsense, it doesn't even make sense, and I haven't even seen a theory or a drawing or any proof to their theory, supporting their theory, sorry, of how this upper atmospheric energy can be harnessed and used and controlled by the pilot, or compressed air. What's driving the compressor? What energy is allowing the compressor to compress the air? Is it batteries? Is it fuel? And if it's fuel, why not use fuel to run the engine? Like, it's so like ridiculous. I had to make this video. I'm going to make the follow-up video. I'm going to tag the same people. If you know the names of these gentlemen, please tag them. I'll look them up and tag them as I go. And I'm looking forward to part 2 of this video, and looking forward to speaking to one or all of them live so we can discuss this. And I want to be able to hear their support for their theory and their thought process, because none of it makes sense. It's quite ridiculous, actually. It's embarrassing, sorry to say.